much.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed.
Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hi, everyone. Thanks for joining us today for our launch of the European Commission's Galileo L13 mission. Falcon 9 is set to lift off from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida, just over 9.5 minutes from now. My name is Ronnie Foreman, and I'm a senior sales manager here at SpaceX. Today's mission is an exciting one. Not only is this mission expected to be our 385th operational mission to date and 90th of 2024, this will also be the 22nd flight of the Falcon 9 booster supporting today's launch. We'll be ending the webcast tonight after booster landing at the request of our customer, so keep an eye on X for confirmation of payload deploy. Unlike the previous Galileo mission, which SpaceX launched in April of this year, today we will be attempting to recover the Falcon 9 booster on your screen. Tonight we'll be using our Droneship. Just read the instructions. Now, as the countdown ticks on, let's take a moment to meet the vehicle and learn a little bit more about what makes Falcon 9, and this booster in particular, so unique. Falcon 9 is a two-stage rocket that is designed and manufactured by SpaceX for the reliable and safe transport of people and payloads into Earth orbit and beyond. It is also the most flown U.S. launch vehicle ever. It is also the first and currently the only orbital-class rocket capable of reflight. The entire rocket stands about 229 feet tall, which is roughly the height of a 21-story building. The bottom two-thirds of the vehicle is the first stage, also referred to as the booster. Not only is the first stage the largest part of the rocket, it's also the portion of the vehicle that we attempt to land for future reuse. Rapid and reliable reusability is key to making life multiplanetary, and every launch is an opportunity for us to learn and inform future missions. To that end, we're working to qualify our fleet of Falcon 9 boosters and fairings to support 40 missions each. During the Galileo L12 mission earlier this year, the Falcon 9 booster was expended, which is just another way to say that it was not recovered. This was done so that the Falcon 9 booster could provide the additional performance needed to deliver the payload to a higher energy orbit. While the booster for Galileo L12 was expended, the data from that mission was still used to help inform changes that will allow us to safely recover and reuse the booster for today's launch. Today's re-entry trajectory will result in higher heating and dynamic pressure on the booster than many of our previous landings. Although the re-entry conditions are on the higher end of past missions, they're still acceptable for flight. And since it's not often that we have a landing attempt that tests the bounds of recovery, this is an extremely valuable opportunity for us to gather actual in-flight data on how the rocket performs in elevated entry conditions. What we learn today will help us innovate on future vehicles. There's the call out from Mission Control that engine chill has begun. What we learn today will help us innovate on future vehicle designs to make our rockets more robust and rapidly reusable, while expanding into more and more challenging re-entry conditions. Now turning our attention back to the pad, above the first stage is our second stage, which has a single Merlin vacuum, or MVAC engine on board, that ignites after the first stage separates. This second stage is what will carry today's Galileo payloads to orbit. And located above the second stage is the payload fairing. At 17 feet...
Stage 1 RP1 load is complete.
Call out for RP1 completion on board our first stage there. And great views of our 17-foot diameter payload fairing on your screen. That fairing is made of carbon composite material that protects the payload on its way to orbit. It will be jettisoned approximately 3 minutes into flight. The fairing halves supporting today's mission are both also flight-proven, although with not quite as high of a flight count as our booster. One fairing half is flying for its 8th time and the other for its 3rd. After separating from the second stage, both fairing halves will return to Earth and be recovered by our recovery vessel, Doug. With that, we are just over 5.5 minutes away from liftoff, and at this point in the countdown, we're waiting for those clamp arms around the base of stage 2 to begin opening up beneath the fairing, and for the TE, which you may also hear called out as the transporter erector or the strongback, to begin pulling away from the rocket in preparation for liftoff. Gorgeous views of Pad 40 there on your screen, too.
Falcon 9 tanks are pressing for strongback retract.
There's that call out that we were preparing for strongback retraction away from the vehicle. Right now, we are standing by to watch those clamp arms begin opening up around the base of stage 2 at roughly T-minus 4 minutes and 17 seconds.
Strongback retract is starting.
Confirmation from Mission Control that strongback retract has begun. And great view of those clamp arms opening up. As always, the white clouds you see forming around the vehicle are totally normal. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of liquid kerosene fuel and liquid oxygen. Both the first and second stages should finish loading propellant about 1 minute apart from each other, and we'll hear those called out by Mission Control. We're expecting final confirmation for the first stage at T-minus 3 minutes, and the second stage shortly thereafter at T-minus 2. Then at T-minus 60 seconds, Falcon 9 will be in startup mode. This means that the rocket's autonomous internal flight computers have taken over the launch countdown. Then, just inside of T-minus 2 seconds, the Merlin 1D engines on the first stage will light in preparation for liftoff. With just over 3 minutes to go, the vehicle continues to be healthy, and the Falcon 9 team is tracking no issues.
Stage 1 LOX load is complete.
There's confirmation of LOX load complete on board the first stage. Now, on board Falcon 9 tonight, there are 2 Galileo satellites, which we should have a view of here in just a second. Galileo is a flagship program for the European Union and one of several global navigation satellite systems, together with the United States' GPS, Russia's GLONASS, and China's Beidou systems. There is that photo of those 2 Galileo spacecraft. This photo was taken earlier this week during encapsulation. The Galileo program currently consists of more than 30 spacecraft that serve approximately 4 billion users. Galileo's open service began in 2017 and provides meter-level accuracy for end users, while the system's high-accuracy service provides sub-meter level accuracy. Each Galileo satellite weighs approximately 700 kilograms and contains 2 payloads, one for navigation and another for search and rescue. Each spacecraft also has 4 atomic clocks that are accurate to within a nanosecond. Tonight's Galileo L13 mission is Falcon 9's second launch supporting the Galileo program.
Stage 2 LOX load is complete.
There's confirmation of Stage 2 LOX load complete. These 2 Galileo satellites are destined for a medium Earth orbit, sometimes called MEO, of approximately 23,200 kilometers.
Ground gas closeout.
Confirmation of ground gas closeout completion. And with that, we are standing by for that call out that Falcon 9 has entered startup mode.
Falcon 9 is in startup.
Confirmation that the onboard flight computers have taken over the countdown. So with that, in this beautiful view on our screen, we are standing by for our launch director's final go for launch.
Go for launch.
Right on schedule. So with that, all systems are go for launch of Falcon 9 and Galileo L13.
Thirty seconds. Fifteen seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Engines full power. And liftoff of Galileo L13. Go SpaceX, go Falcon.
Vehicle is pitching dead range.
Stage 1 propulsion is nominal.
These beautiful tracking views, of course, mean that Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral, and the vehicle is throttling down its first stage engines as it prepares for max Q, about 1 minute and 10 seconds into flight.
Power and telemetry nominal.
Confirmation that everything's looking good on board Falcon 9. Now, max Q is a critical
Falcon
ascent.
9 is supersonic.
And confirmation that Falcon 9 is moving faster than the speed of sound. Max Q is a critical ascent milestone that we track for every mission because this is the moment in flight with the highest amount of aerodynamic pressure.
Max Q.
And with that confirmation, we have 3 events coming up in quick succession, starting with main engine cutoff, stage separation, and then second engine start 1. Main engine cutoff, or MECO for short, is where all 9 M1D engines on the first stage will shut down in preparation for stage separation, when the first stage separates from the second stage. Stage 2 will then perform second engine start 1,
MVAC
or
chill has started.
SES-1, igniting our single MVAC engine for the first time. MVAC is what Falcon 9 uses to propel the second stage to orbit. After that, we'll also keep an eye open for fairing separation, as we are expecting to see the fairing halves separate a little less than a minute after SES-1.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
So there we have confirmation of main engine cutoff, stage separation, and SES-1. Next up, we're expecting to see and hear confirmation of payload fairing separation. We are attempting to retrieve these fairing halves once they fall back down to Earth using our recovery ship, Doug. And fun fact, this is our 242nd mission to use a previously flown fairing. While we stand by for fairing separation, we do have great views on your screen right here.
Nominal trajectories.
And confirmation of nominal trajectories for both vehicles.
Fairing separation confirmed.
Great view and audio there from Mission Control of fairing separation. Now from here on out, our 2 stages are following different trajectories. As the first stage prepares for its landing attempt on our drone ship, just read the instructions, and the second stage continues taking the Galileo payloads to orbit. Great view of our first stage as it starts making its way back to Earth here. Those grid fins that you can see on the side of the booster are about 4 by 5 feet. Just for reference, that's about the size of an average coffee table. Now, as you can see on the right-hand side of your screen, Falcon 9's second stage is making its way to orbit, roughly at an altitude of 140 kilometers, traveling more than 11,000 kilometers per hour. Telemetry is a crucial aspect of any space mission, providing mission control with real-time data about the health and status of the rocket and its systems. For those of you watching along at home, you'll notice some important telemetry data is always displayed on your screen throughout a launch. On the bottom left, you can see the speed and altitude of the first stage. This data shows the first stage elevation and how fast the stage is traveling as it makes its way back to Earth. We are coming up also on 2 engine burns that will be used to help slow the booster down as it attempts to land on our drone ship, which tonight is Just Read the Instructions, currently stationed downrange from the launch site in the Atlantic Ocean. And then on the bottom right-hand corner of your screen, you can see the speed and altitude of the second stage as it continues to take our Galileo spacecraft to orbit. We are just over 5.5 minutes into today's mission, and in case you're just joining us, we did have an on-time liftoff tonight at 6:40 p.m. Eastern from Cape Canaveral Space Force Station in Florida, followed by successful main engine cutoff, stage separation, and second engine start 1. Quick correction there, 6:50 Eastern liftoff. And now we are standing by for our first stage reentry and landing.
Nominal trajectories.
And confirmation that both vehicles are still on nominal trajectories. To start the upcoming entry burn, we'll relight 3 of the M1D engines on board the first stage.
Stage 1 entry burn startup.
Right on schedule.
Stage 1 FTSS safed.
We need to do this entry burn to help slow the vehicle down as it passes back into the Earth's atmosphere to reduce re-entry forces. That will help us, in turn, recover and reuse this booster on future flights. During this re-entry burn, Falcon 9 is...
Stage 1 entry burn shutdown.
There's confirmation of entry burn shutdown. So while we've decelerated some by firing those Merlin engines, we're still moving really fast. That causes the rocket to fly through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle's surface. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little bit more on the outside of the rocket. As I mentioned earlier, you can continue to track the first stage telemetry in the
Stage
bottom
2 terminal guidance.
left-hand corner of your screen. As the booster continues to make its way to our drone ship, just read the instructions. Reusability is key to lowering the cost of spaceflight, which enables more investment in critical space infrastructure. The Falcon 9 first stage supporting today's mission has now performed its entry burn for the 22nd time.
Stage 1 transonic.
Confirmation that
Stage 2
our
FTSS safed.
booster is transonic. And right now we are standing by for landing burn start on board the first stage in just about 10 seconds.
Stage 1 landing burn.
Confirmation of landing burn startup.
Landing leg deploy. Stage 1 landing confirmed.
And confirmation of first stage landing. This was the 22nd launch and landing for this first stage. This landing marks SpaceX's 349th recovery of an orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy, and confirmation of nominal orbital insertion by our second stage. Now, with those confirmations, we are going to bring today's webcast to a close. The second stage still has another burn coming up, just over 3 hours and 26 minutes into today's mission to finalize the orbit for deployment of the Galileo spacecraft. Be sure to keep an eye on our X account for confirmation of payload deploy and our customer's website to learn more about today's mission. If you're interested in even more launch coverage, be sure to check spacex.com/launches for the most up-to-date information. Today's mission marked SpaceX's 385th operational mission to date and 90th this year. This was, again, the 22nd launch for this Falcon 9 first stage booster and our 349th landing. A big thank you to our customer for this mission, the European Commission, and also to the Eastern Range and Coast Guard for their continued support. And of course, thank you for tuning in. We'll see you again soon.